adapt and learn from vast amount of data. Basically, neural network is one type of machine learning. Machine learning is not only confined to the neural networks. There are so many algorithms are available. Deep learning is artificial neural network which will adapt and learn from vast amounts of data. Then in machine learning, as I said, machine learning is comprising of so many techniques, not only neural networks. The people will think that when we are talking about machine learning and deep learning, they will be concerned with only the neural networks. It is not only neural networks, it has so many wider algorithms. Okay, now this is about what is machine learning. Now there is a one word is there, it is called a model, machine learning model. The people will confuse that whether the machine learning algorithm and machine learning model are same or different. My answer is different. Machine learning algorithms are just theoretical concepts which will describe the task to be done to achieve the specific effect or outcome. So those theoretical concepts are called machine learning algorithms. When we form a mathematical model for those conceptual algorithms, then it is called a mathematical model, right? So we know the difference between the algorithm and model from this picture. So algorithm is like step-by-step concept which we are going to do from the input to the output. What are the decisions we are going to take? What are the process we are going to implement? So those theoretical concepts are called as an algorithm. So when we are making it to a mathematical model with the equations and parameters, then that will become a model. So the data is represented from x1 to xn. Then the model, mathematical model, will relate these inputs to the output y. So this model will give you an output that is called maybe a prediction, or it may be a regression, some sort of output it is going to give. So this total together is called as a mathematical model. Now each and every parameters which is available in this mathematical model are fine-tuned based on the theoretical concepts of the algorithm, so that your model will give you the correct predicted output. And now this is the difference between machine learning algorithm and machine learning model. Okay, now with this background, I am going into the types of the machine learning algorithms. So basically there are three different types are available. Three different classifications are available in machine learning algorithms. In some websites or in some textbooks, they will add one more also. They will call it as semi-supervised learning. So that can also be included, but I want to concentrate only both on the main classifications of machine learning algorithms, right? So most of the people, those who are working in machine learning algorithms, my lecture is going to be a revision of the topics only. So I'm not going to take any new, new case studies, or I'm not going to talk about any results and research outcomes. It's like a revision of what the concepts they know already. So which will help them in understanding the concepts of each and every one in the 4 days FDB, 5 days FDB. It's going to come in remaining days, right? Now, the machine learning algorithms are generally classified into three types: supervised learning, unsupervised learning, and reinforcement learning. So all are having a distinction. The supervised learning will have the label. I have a detailed explanation. I will explain it. Just I'm giving you a glimpse. The supervised learning will have a label. So inputs are taken as xn, yns are corresponding outputs. So these two will be given to the machine learning algorithm or software application. So based on this data, it will train itself to act upon the new data. So this is called supervised learning. In unsupervised learning, we will be having only the data. So the data is given to that software algorithm. That software algorithm will, based on the data driven, so that algorithm will decide the output. Then reinforcement learning is completely a new area. Rather than this, we cannot say it is supervised or unsupervised. It is a new area where we will be having agents. That agents will learn from the environment. Legends were learned from the environment. Okay, now what are all the applications where we will be using all these categories? I have listed out here. So mostly that supervised learning is used for prediction, classification, and regression. So when it comes to the classifications, it may be a discrete labels also. Regression, their real values will be there. So these three areas where the supervised learning is finding the most applications. Then when it comes to the unsupervised learning, four different areas are there: clustering, probability distribution estimation, or otherwise it is called a principal component analysis also. Then association rules, then dimensionality reduction. So these are all the four areas where it's unsupervised learning is finding more applications. Then when it comes to reinforcement learning, like gaming, decision making, so all those areas, the reinforcement learning is applied, right? Now, how it is classified, this ML types, I want to explain with these two diagrams. So first one, if you are taking a supervised learning, unsupervised learning, and reinforcement learning, the supervised learning is task driven. So the process will take the much weightage in it. So the process will decide the output of the algorithm. So it may be a classification or regression. So the task, the process will decide the output. So this is about supervised learning. When it comes to unsupervised learning, it is a data driven rather than the task. The data is driving the algorithm to produce the output. The weightage is more for the data. So the output may not be a correct one, but it will give you the output based on the data. So this is an example for the clustering. Clustering is one of the example for the unsupervised learning. Now coming to the reinforcement learning comes from learning from the mistakes. Learning from the mistakes. The agent is allowed to do a mistake. So based on that mistake, it will be rewarded or penalized. So we will see how it happens. So this is learning from the mistakes. So these three are different distinctions are there. Okay, now coming to this picture, right? Now basically the supervised learning will have a teacher, right? So the name supervised itself came because there will be the guidance will be available for training of that particular algorithm. So as a manual person who is writing the code, he will be attaching each and every data with a label. So this data and label pair will form a supervised learning environment for that algorithm. Based on that, it will get trained. Okay. So this supervised learning will have a teacher. So this teacher will dictate what to do. Now coming to the unsupervised learning, it's like what we are learning as of own. Like suppose new concept, if you want to learn, we will learn based on our readings and our books and our references in the websites. So we will learn by ourselves without any teacher. We will try to interpret the information what is available on the resources. We will try to gain the knowledge from those resources. So those are all called unsupervised learning. Then in reinforcement learning, it's like how our father has corrected our mistakes. So as a young child, we will be doing a mistakes. So our father and relatives will come and correct our mistakes, and they will say what is the right one and what is the wrong one. So based on that, we will learn so many things. So that is called reinforcement learning. So these are all the three broader areas where we are going to focus in this slides. Right. Now this picture, most of you have seen in the websites. Of course, if you are Googling it in the images, what is a machine learning, you will get this picture. So the machine learning is having three broader areas: supervised, unsupervised, and reinforcement. So when it comes to supervised, it is mainly applied for classification and regression. Then if you are finding out the examples, there are the examples are given. So it may be used for fraud detection, image classification, customer retention, and diagnostics. When it comes to regression, forecasting, prediction, process optimization, and new insights. So basically, I'm working on this forecasting area. I'm forecasting my electricity demand for the smart grids and the electric grids, and I'm doing the renewable energy forecasting for a particular area. So this is my area of working now. Then when it comes to the unsupervised learning, mainly it is used for two different areas, clustering and dimensionality reduction. So if you are going for clustering examples, we can have recommended system, targeted marketing, and customer segmentation. Then when it comes to the dimensionality reductions, we have big data visualization, meaningful compression, structural delivery, and future elucidation. Then when coming to the reinforcement learning, so this reinforcement learning, it's a new area which is emerging now. So I can say for the 4 or 5 years, this reinforcement learning is finding applications in various places. So this reinforcement learning is mainly used in these areas like real-time decisions, game AI, learning tasks, skill acquisition, and robot navigations. So this robot navigations finding very much applications of this new reinforcement learning algorithms. So slightly I'm involved in this research area also. So I'm doing robot navigations algorithms for the simple robots. Okay, now this is the broader classifications, broader picture of your machine learning algorithms. Right, now I am going to explain about each and every learning algorithms. I mean main classifications of the algorithms. Let me start with supervised learning algorithm. So a supervised learning algorithm is a system which is given with the label. As I told you earlier, it is given with a label. So each and every data is tackled with the correct label. So this algorithms will require a data set which will have the input and output pair. So input is also needed. The correct output for that input is also needed for supervised learning. So each pair of the data sample used to make prediction and expected outcome called the label. Right. So each and every data set which is available in the input data is given to the algorithm, and that algorithm will try to find out the expected outcome. So that expected outcome is called a label. The goal or the basic idea is to find out the approximate mapping function which will map the output variable and the input data. So mathematically we can simply explain that y that is equal to f of x, right? So of course there will be some b term is also will come. This f of x will have some mx plus b. So those things we will see later on when we are going for the linear regression. But when we go for multiple regression, this fx will vary. But in general, in supervised learning, we are trying to find out the mapping function which relates the output variable with the set of input variables. Right. Now this is the basic process flow, what is happening in the supervised learning algorithm, right? So there will be a training data set. So the people, those who are working in neural networks and other learning algorithms, they will understand what I am calling about training data set. So training data set is that known data set what we have already. For each and every sample, we will be having the expected outcome. So we will be having sample 0 with the expected result 0. Like that, we will be having m number of samples with the m number of expected results. So all these things are fed to the model, right? So this fitting to the model is iteratively done. There are so many different ways are there how to give the training data set to the model, maybe a batch mode or single mode. So those things are advanced topics we will see later on when we are going for a specific learning algorithm. Right. So this data set is given to the model iteratively. So this model is made to do a prediction for each and every sample. So it is made to make a prediction for each and every sample. Now this model is giving an output that is called prediction. Now this prediction is compared with the expected results. So this prediction is compared with the expected results. Based on that, error is calculated. Now this error calculations, there are so many error terms are there. So we can fix that error term for the particular problem. But the general flow is we will be finding out an error. Now based on that error, the model parameters are modified. So you know that model I have shown you. Yeah. So here there are parameters are called W naught to Wn, and we have a B also. So this W naught to Wn in neural networks, it is called weights. Then this B is called bias. So these parameters are modified. These parameters are modified according to the error. Then these modifications are done on the model. Right? Any doubt? So for any doubt, I can see some noise in the slides. Any doubt? Okay, right. If there is no, we can go for it. Right. Now this is the basic process flow. Now based on this process flow, each and every supervised learning algorithm will work, but there will be a slighter modifications according to the specific purpose which is used for it. Suppose for the classifications, there will be changes in the model. For the regression, there will be a changes in the model, but the general process flow will be this one. Right. Now this is a simple example for a supervised learning. Basically, it is a classification problem. So the computer system or our Gmail, the mail system is an AI system which will classify our mail, whether it is a spam or not. Right. So initially what happens, that software algorithm will be given with the n number of data, which is containing spam mail as well as not spam mail. Of course, it is labeled. So each and every data is given with the correct outcome. So that the system gets learned. Okay. Now that model is given with a new mail. So this new mail is going to the process. Then there is a categorical separation, whether it is spam or not spam. Okay. So this is the a very basic example of the classification problem happening with supervised learning algorithm. Okay, right. Now, when we are going for supervised learning, as I told you earlier, there are two major types are there based on the application, classification and regression. So what is classification? Classification is a process of assigning category to input data sample. So the process of assigning the category to the input data sample is called classification. Right. Now this classification is example I can give, like predicting the person whether it is in good health condition or not, or is the transaction is fraudulent, or if the classification of the face is changing or not. Okay. Now these are all the simple examples what I can give it for the classification. Then coming to the regression. So the regression is the process of predicting a continuous numerical value for input data sample. Right. So we are giving with some n number of data to it, and that n number of data is fitted into a regression line. And then from the regression line, we are going to find out the new value for the new data. So this is called regression. We will see in detail the types also we will see in detail for the classification as well as regression. Now, what is the example usage we can give us? Assessing the house price. So we will be having a historical data for the house price in a particular area. So that historical data is given to the learning algorithm. That learning algorithm will decide the house price for the present conditions. So that is one example we can give. Then the another example is forecasting the grocery store food demand. Suppose if there is any grocery store is there, now what will be the food demand for the next day, or for the 1 week, or for any festival day. So those food demand calculation can be done with the regression algorithm. Then of course the weather prediction. So the temperature forecasting of a particular area can be done with the regression models. Okay, these are all the major classifications of the supervised learning. Right. Now this both classification and regression is given in a diagram. So we are having two different genes. It is called a gene, but it is a data. So two different data are available. Now this data is scattered one. Now it is the line, which is model is represented with a line, that the ML algorithm the results will become a line. That line is classifying these two categories. So these are all the people are healthy people, and these are all the people are having some diseases. So the classification algorithm will provide a result like a line which is classifying the two different categories. Two different categories. Of course, we can go for the multiple categories. There are multiple linear regressions and clustering algorithms. So many things are there. This is a basic idea. Then, when coming to the regression, so we have a people are there for their life expectancies samples. Data are available. This is a data, a huge amount of the data. Now this data is made to make one regression model. That regression model will become a line. So this regression model can be further extended. Say for example, this is for the present condition. This is a line that based on that line, we can extend it for the future also. Right? So this is about the regression. So I think the clear distinction can be understood from these two pictures. So this is classifying the data into two parts, and this is extending the data points, the future predictions also. This is called regression. Okay. Right. Now, what are the common supervised learning algorithms which is finding mostly in literature? So I have listed out few. Regression, linear regression, nearest neighbor, naive Bayes, and decision trees, random forest, support vector machines, and neural networks. So these are all the common supervised learning algorithms. Now, out of which we are going to see almost 5 algorithms in our, in our FTP sessions. So we don't have support vector machines and we don't have a neural networks, but of course, all these 5 topics we are going to see it in the FTP. Okay. Now these are all the common examples of the supervised learning algorithms. Okay. Now I am going for the unsupervised learning algorithm. First, we will see the classifications. Then we will go one by one of algorithms, like what is when be a linear regression, what is when be a nearest neighbor. So all those things we will see once we see the classifications. Right? Okay. Now, coming to the unsupervised learning. So what is unsupervised learning? So as I told you earlier, there will be no label here. So we don't know what is the known result for the data. So what will be the expected outcome of the data, we don't know. So it is a group of algorithms that try to draw inferences from the unlabeled data. Okay. So from the unlabeled data, how we are going to draw the inferences. So that is the main theme of the unsupervised learning algorithm. So it is an AI system presented with unlabeled, uncategorized data, and the system's algorithms are acting on the data without period training. As I told you earlier, it is data-driven algorithms. Okay, so the process is same. It is not going to change. The process is same. The data is going to drive these system algorithms so that the outcome will vary based on the data. Okay. Then we can say that this is depending upon the coded algorithms, and hence there are no correct answers. Okay. The output is the algorithm what it dictates to do. Then the data will act upon that algorithms. Then the output will come. But we cannot say it is a correct answer or not. We cannot say correct answer or not. But we can say how much probable it is correct or not. Say some output is coming, we can say it is 90% maybe correct. So those type of results only we can get from this unsupervised learning algorithms. Right. Now this is a classical example of unsupervised learning. Suppose we have so many number of pictures are there, so many animals are there. When you are providing the unsupervised learning, it is doing a classification. So one classification, it is taking all the ducks into one group. And in another classifications, it is putting all other animal cartoon pictures. Okay. So this is one type of unsupervised learning. So this data is not given with any label. So it is given to that algorithm. So this algorithm learns by itself, and it separates two groups. One is all the ducks in that given data set, and all other animal cartoon pictures are taken outside. So these type of groups are came as an output from this unsupervised learning. This is one of the simple example. Right. Now coming to the another example, which will explain the basic process flow. So unsupervised learning, there is a training set data set is available. This training data set is having different shape and in different colors, different shape in different colors. So square is there, ellipse is there, circle is there, hexagon is there. So all other shapes are forming a data set, and this is fed into the model. It is fed into the model, and the job is that it has to find out the pattern and separate. It has to find out the pattern and separate. Basically, it has to cluster it. So all those circular shapes are clustered to one cluster or one group, and all the square shapes are grouped into one group. And likewise, it is grouped into it. And of course, if you want to design a model which will segregate the colors, so that also we can do it in this model. So that's what is the model is dictating that based on that model, the output will come. Okay, suppose instead of having the shape-wise segregation, suppose if you want to do it with the color-wise segregation, that also you can do. Color-wise segregation also we can do. So those type of algorithms are called unsupervised learning algorithms. Right. So the major types of unsupervised learning algorithms based on the applications is clustering algorithms, then data dimensionality reduction, and one more is there that is called association. That is called association. Okay. Now what it says, what is the meaning of clustering? So the clustering is process of dividing and grouping the similar data samples together. So we want to divide the given data set and we have to group it with the similar data. So the example usages, we can give segmentation of the supermarkets, user-based segmentation, and signal denoising. Right? So these are all the very simple examples, usages of clustering algorithms. Now coming to the dimensionality reduction. What is dimensionality reduction? It is a process of compressing features into a so-called principal values, which conveys similar information concisely. Okay, and we want to compress features of a particular data set into a principal values. That principal values will convey the similar information concisely. So this is the idea behind the dimensionality reduction. Now the example usage, mostly it is used to speed up the process of the ML algorithms. Then we can find the reliable features in a data set from a group, or we can say finding a group of most reliable features in a data. These are all the example usages. And one more thing is there that is called association. What is association? Association rule is a learning problem where we want to find out the rules which will describe large portions of the data like that some belongs to X, some belongs to Y, or like how many percentage of the people belongs to X as well as Y, or how many percentage of the people belongs to Y and belongs to X, like a Venn diagram, So these are all the association rules. Is another type of learning algorithms based on the application. Okay. Now these are all about the unsupervised learning algorithms. Right. This is one example of clustering based on the unsupervised learning algorithms. So where the countries present in the world are classified into 3 different types. So there are so many parameters are taken, like life expectancy, gross national income, mortality rate, expected years of schooling. So all those data are taken based on the data. The clustering process has happened, like how many countries are developed countries, how many countries are developing countries, and how many countries are underdeveloped countries. So this is one of the classical example for clustering problem of unsupervised learning. Clustering problem of unsupervised learning. Okay. Right. What are the common unsupervised learning algorithms? So K-means clustering, principal component analysis, and association rules. Now in this, we are going to see k-means clustering in our FDP. The detailed analysis, we will do detailed implementation of the Python, everything we are going to learn for the k-means clustering. Now coming to the reinforcement learning. There is, as I told you already, this reinforcement learning is a new area, and it is a different than uh, supervised learning as well as unsupervised learning. The area, I mean, the approach what we are doing for developing these algorithms are completely different from the other two algorithms, right? Now, this reinforcement learning is a branch of ML algorithms which produces so-called agents, right? The outcome of these algorithms are called agents. Now, this modeling of this agent or role of this agent is different from the classical models, right? Now, this model will receive the information from the environment and reacts to it by performing an action. We will see an example what it means. I will explain in clear. An agent learns by interacting with its environment. So that is very, very important. That environment may be dynamic in nature also. So that environment may be dynamic in nature also, meaning that the parameters available in that environment may change dynamically. So our agent has to learn from that dynamically changing environment. Accordingly, it has to act. Accordingly, it has to act. So it is a very interesting research area where the people are working rigorously. So many papers are coming from this reinforcement learning. Of course, deep learning, integrated reinforcement learning also there, like deep reinforcement learning. So it is a hottest area where researches are going on. Right. Now, the basic process flow is the agent will receive rewards or penalty for performing correctly as well as for performing incorrectly, respectively. So if it performs correctly, it will be given with a reward. If it is doing wrongly, it will be penalized. Now this penalty and reward we can decide. It may be numbers or it may be binary variables. It can be decided based on the problem. It can be decided based on the problem. The beauty of is that it is learning, that the agent is learning without the intervention of the human. Even though environment is changing, so without the intervention of the human, it learns. How it learns? By maximizing the reward and minimizing the penalty. So of course, there will be optimization algorithms will also come into play. So where it will help the agent to maximize the reward and minimize the penalty. Okay. Now, what is that the process flow of reinforcement learning? That can be explained with this model. So the agent is an algorithm. So this algorithm is embodied on one environment. This environment will have parameters as well as this agent is also having some parameters. So we are going to change the parameters of the agent so that it will perform an action which will give the reward from the environment, which will give the reward from the environment. Basically, this state is a data. So this environment is going to have so many data that data is provided as a state to the agent, right? Now this agent will get that state, and based on the state, it will do some action. That action is given to the environment, so that environment will provide a reward. This reward may be a penalty. If it is not doing the required action, it may be a penalty also, right? So this is the flow, a general flow, basic flow in reinforcement learning algorithms. Okay. Now this is an example. Suppose let us say one small robot is there. Let's call it as an agent. That agent is going to follow a safer path. It has to follow a safer path to reach its destination. To reach its destination, let us imagine that it is placed in any industry or organization. Now, this agent is looking for two different paths. Of course, there will be a middle path is also possible. Now, two different paths are there. If it goes through this fire path, it it is going to get damaged. So which is not desirable for us. It can follow the water path also. Still, it is not desirable. But when it comes to comparison between these two, this is more dangerous than this, right? So of course, this robot has to avoid these two environments. It has to follow the middle path. It has to follow the middle path. That is that idea, right? So if the agent is coming to the fire and if it touches over here, if that robot is coming over here, touches over it, then it has to be rewarded with a penalty. It has to be given with a penalty. The penalty may be points or it may be discrete values. Here, let us say it is a points. So there will be a total point. The total point is reduced by -50. And of course, if it comes to this water path also, it has to be penalized. But the penalty is not equal to this -50. Maybe it is equal to the -10 or -15 or something. So what that agent is learning from this experience is that next time it should not take the fire path. So it is a bad thing. So it has to learn that decision. It has to learn that environment. So this is the idea behind the reinforcement learning. So this agent is fed with so many dynamically changing environment. So based on the dynamically changing environment, it will learn. It will learn what is the correct one, what is the bad one, what is nearest to the correct one. All those learning process will happen. So this process will iteratively done until the optimal path is found out. Until the optimal path is found out. So this is the basic idea behind the reinforcement learning. Right. Now, what are the common reinforcement learning algorithms? Q learning, temporal difference, and deep adversarial networks. Right. So these are all the three common reinforcement learning algorithms. Right. Now, I want to explain about what are all the ML algorithms, what we are going to see in detail for this FTP course. Now, before that, I want to assure one thing, whether is there any doubts? The participants, whether do we have any doubts? Any doubts regarding this, whatever so far I covered? Yeah, whether are you with me? Okay, okay. Right. So I want to give a basic ideas about the ML algorithms. What are all the algorithms? We are going to see it in this FTP, right? So I repeatedly saying I am not going to cover all the ML algorithms, so which will take much of the time. So what are all the topics we are going to see it in this FTP? I am going to touch upon, not fully, just to give an idea what is what. Just to give idea what is what. Okay. Now first a linear regression. So basically, what is a linear regression? And one more thing I want to stress it here is I am not segregating the algorithms into different ways. I mean, I don't want to follow like classification algorithms first, then regression algorithms second, third unsupervised algorithms. Likewise, I don't want to segregate it. I don't want to segregate it. So I am following the topics order what is given in the FDP. Topics order which is given in the FDP. Okay, right? So why I am stressing this is you may feel that why he jumps here and there. He can explain classification first, then he can go for regression second. So you may feel that. So for that information, I am telling you in the beginning itself. So a linear regression, what is a linear regression? It is predicting a value based on the historical data. So there will be independent variables will be available. Or if it is a single linear regression, the data for a single independent variable will be available for um, so many years. Based on that independent variable, we are finding out the dependent variable. Okay, so the data points will be available here. Then there will be line of regression will be available based on this each and every data point. I hope you know how this line will be arrived based on the taking average of all these data points. This line is formed. This line is formed. Okay, right? Uh, this is basically a linear regression. Basically, it is a linear regression. Why it is called a linear? Because the line of regression, what we are forming, it will be like a straight line. So that is why it is called linear. So if you are taking one more point here, that is linearly extrapolated. Suppose if you are taking another point here, again it is linearly extrapolated. Okay, so the difference will be same. Whatever the data points you are taking on the line of regression, the difference will be same between the two suggestion points. Okay, so that is why it is called a linear regression. I have a simple example how that the salary of a person depends on the experience. Salary of the person depends on the experience. So naturally, when you have a less experience, your salary will be low. When you go for the higher experiences, your salary will be higher, right? So now with this data set, with this data points, we can predict a person's salary in next month or in next year. So the data points can be formed as a line. That line can be extrapolated for the next year or next month. Okay. So this is the basic example for the linear regression. So in the corresponding chapter, we will see how to form the mathematical model for this linear regression, how to implement it in the Python, how to run it in the Colab. So all those things we will see in the corresponding session. This is to give a basic idea. Okay. Now this is about linear regression. Now what is multilinear regression? Right, multilinear regression, we will be having more than one variable. More than one variable. So x1, x2 up to xp all are different set of datas, not a single data, different datas, x1, x2 up to xp, right? Then based on this, we are forming a line. So we are forming a line, we are trying to forming a line based on averaging it out, and we are trying to find out this equation which will depicts all the data points in a single mathematical model. Okay, now this is called multiple linear regression. Okay, what is the example I can give? Suppose you want to find out the batting average of a particular person, or let us say batting average also a data point. Suppose you want to predict how the person or how the cricketer performs well in batting situations, how he performs well in batting situations. You want to predict that for the next session of test series or next season of one-day international series, you want to see how he will perform in batting conditions, right? So for doing that, we are taking so many data. So like how many runs he scored, single run scores he scored at a bat, and how many doubles he scored, and how many times he scored the doubles. Then what is his batting average? Likewise, we can go for how many sixes he scored, how many centuries he scored. Like that, we can have so many data sets. All are integrated together. And finally, we can find out the answer for Y, correlating all these data points into a single equation. All these data points into a single equation. So this is called a multilinear regression. So it is not only going to have a single data points, it is going to have multiple data points. So I'm telling you the difference. So here we are going to have only experience as the independent variable. Experience as the independent variable. But here we are going to have so many independent variables. So many independent variables. So based on these independence variables, we are going to find out one dependent variable, that is called multilinear regression. Not only one dependent, maybe one or two dependent variables we are going to find out. So that is called multiple linear regression. Okay. Hope I'm clear about my concept. Then another regression model is there, that is called a logistic regression. There is a clear difference between the linear regression and the logistic regression. The linear regressions, the outcome will be continuous data. The outcome will be continuous data. Say, for example, if you are taking this example, the salary is a continuous one. So you will be having the next salary in between 1,20,000 to 1,40,000 or something like that. So it is a continuous data will become as an output. Same way here also we will be getting a continuous data as an output. So this is about linear regressions. Now coming to the logistic regression, the output will be a binary one, either 0 or 1. So that is very, very, very important. Say, suppose you want to find out whether that particular cricketer will be selected for the next test series, right? So if he is selected, then output will be 1. If he is not selected, the output will be 0. So this is a problem of logistic regression. Now, here what I explained is how he will perform in the next series. So that is called a linear regression. So that is a clear difference. So this is says about the performance in the next series, and this is says about whether he is in or not, whether he is selected or not. So that is called logistic regression. So for logistic regression, we will be introducing one more function. That function is called a sigmoidal function. So all those data values are given to the linear model. So this linear model will provide the probabilities. Now these probabilities are given to the sigmoidal function. That sigmoidal function will give you the binary value. Either it is 0.9 or 0.1, right? So the output will be 0 or 1 based on this, right? So for the logistic regression, the output will be either 0 or 1. The output will not fall outside of this. Output will not fall outside of this. But here, when we are going for linear regression, there is no constraint. So the output may be of any value. The output may be of any value, right? Okay. Now this is another picture which will provide the clear difference between the linear regression and logistic regression. So if you are taking a linear regression, the variable independent variables are here. Now the dependent variable is a continuous output. Dependent variable is a continuous output. All the data points can take any value. All the data points can take any value. Now based on the data points value, that's the line of regression is formed. Okay. Now when it comes to the logistic regression, the logistic regression is going to provide the two outputs, 0 or 1. Or here it is represented class A or class B. Either the output belongs to class A or output belongs to class B. Exactly what I am trying to do is I am going to group the data points into two classes. Either it belongs to class A or either it belongs to class B. Okay. Now that is the idea. So here there is a sigmoidal function. The sigmoidal function will act upon the data points and it will classify whether it belongs to class A or class B. So there will be a threshold point will be there. If the threshold point is crossed, that probability is crossed that threshold point, all are moved to class B. If the threshold value, the probability is lesser than the threshold value, it will be moved to class A. So this is the idea behind logistic regression. Okay. Right. Now, coming to the classification problem. So K nearest neighbor, KNN model, it is a supervised learning algorithm. Here, the classifications are done over here. Say for example, there is a data set is available which is consisting of a cat and dog. Now you are giving one input value. The classifier is trained to classify the cat as well as dog into two separate groups. So you are giving a cat picture to it and the classifier will produce the output as a cat. So or I can say it will put this input data into the cluster of a cat. Okay. So this is the basic idea behind the KNN classifier. Your predicted output will be a group of a group of data, a group of data. Okay, this is called k nearest neighbor. Okay, now this is will explain that k nearest neighbor in detail. Say already we have two category of points are available, two data points are available. So x1 is one data point and x2 is another data point. We have a category A and category B. Now one new data point is coming and it is over here. Before KNN, sorry. Now before application of the KNN, we don't know where to put this new data point. Now when we are putting the KNN classifier, right, it will take the centroid of this category A and it will take the centroid of this category B, and it will try to find out this distance between the centroid point to this new data point and this category B centroid point to this new data point, and it will find out the nearest value, I mean small value. So which one is smaller, that category, this new point will be added to it. So in this example, this new data point is assigned to the category A based on the distance between centroid of this category A to this new point, centroid of this category B to this new point. Which one is smaller? That group it will be assigned. That group it will be assigned. Of course, if this is assigned to this group, naturally this centroid point will vary. Okay, those are all implementation part. We will do in Python. At that time, we will try to understand what happens over here. Okay. Now this is about nearest neighbor algorithm or KNN model. Simply it is called KNN model. Right. The next one classifier is a naive-based classifier. Basically, it is more probability-oriented classification algorithm. The implementation also involves more mathematical equations and more mathematical formulations are involved in this. How it works upon, it is explained over here. Say, for example, I want to predict the probability of A occurring. So I want to find out whether the A will occur or not, right? Given that the evidence B has already occurred. So the correlated evidence B is there, that is has already occurred. So I want to find out the probability of A. Now how I can get it out? Based on the classifier. So the probability of B occurring given evidence A has already occurred multiplied by probability of A occurring divided by probability of B occurring. So this is the algorithm. A basic base classifier. Of course, there are modifications also there. The probability distributions, so many probability distributions are there. Based on that, classifiers has changed, like Gaussian Bayes algorithm. So many modifications are there. The basic idea is based on the probability, it has been classified. Okay. Now, the same thing is explained with this different picture. So it is a family of simple probability classifier based on the Bayes theorem with the strong independent assumptions between the features. So we can say in the Bayesian's probability terminology, this above equation simply can be told like this. Posterior is equal to period and multiplied with the likelihood divided by evidence. Okay, so posterior in the sense that next occurring point, how it will be taken off. It is taken off with the period evidence multiplied by likelihood of having this probability divided by how this evidence has happened. Okay, now this is about the Bayes classifier. Okay, now if you are looking at this picture, this picture will give you the idea how this Bayes classifier will work. Now there are three clear distinction of classifiers are available. There are some overlappings are available. That overlappings, how it is clustered. This clustering is happened because of this probability formula. Say here, this one belongs to the red and this one belongs to the blue and this one belongs to the red. Now these two are belonging to the red decided based on this probability. Similarly, this blue belongs to this this group decided based on this probability. Okay. Now this is about Bayes classifier. Again, it is also a supervised learning algorithm. but it involves with so many uh, probability calculations. Right. Now coming to the decision tree. So the next one is decision tree. This decision tree will have two different nodes. So one is decision node and another one is a leaf node. So it will be formed like a tree structure. So there will be a root node. From the root node, the subtrees will be formed. From the subtrees, the branches will be formed. So here one example for the subtree, and here there is a branches are there. So each and every stage will have some decisions. So decision node will decide about the decision making. Leaf node is the outcome. So based on this decision, there are two outcomes. So based on this decision, there is one outcome and another possibility of another decision making. So based on this decision, there are two outcomes are there. So leaf nodes are talking about the outcomes. Decision nodes are talking about the decision making criteria, right? So each and every data sets are classified based on this decision tree to find out the outputs. Okay, now this is a very simple example. With this, you can understand what the decision tree is going to do. Say some person is going to decide whether to accept the job or not. Okay. Now the first decision based on the criteria, what he is looking is whether the salary is between 50,000 to 80,000. The salary is given with the 50,000 to 80,000. Now whether he is accepting or not. If he is comfortable with that salary, he will going to accept it. Otherwise, it is going to be declined. So each and every branches are giving about the rule whether to accept or not. Okay. Then if he is accepting it, then he is putting another decision making condition, whether the office is nearer to the home. If it is nearer to the home, he will accept, or otherwise he will go declining the offer. Right? Okay. Then if there is a cap facility or not. If there is a cap facility or not. If it is available, then he will accept the offer. Otherwise, he will go for declining the offer. So this is very simple classical example of how the decision tree works. Right? So the each and every data set is given to here. Based on that, this process is going on, and the decisions are taken over here. So this is about decision tree. Right. Now coming to the random forest. Random forest is also a type of decision tree algorithm where there will be more number of training set, and each and every training data are given to the decision trees. Finally, there will be an averaging. Based on that averaging, the prediction will happen. Say, for example, we have n number of training data. Those n number of training data is given to the n number of decision trees. Now, each and every decision tree will provide one prediction. Those predictions are averaged. It is called a voting process. Like it's all are averaged. Finally, based on that average, the prediction comes over here. Right? So this is about a random forest. So basically, these two are different. So this decision tree is integral part of the random process. So look at here, this decision tree is integral part of the random process. Right. Now this is one example. Say for example, we have a fruits placed in the box, right? So this is placed over here. Now we want to find out which class of fruits are available here. Okay. So each and everything is given to a decision tree. This decision tree will have its own rule, right? So each and every decision tree will have its own rule. Now based on that rules, each and every tree provides the output. So the outcome of tree 1 is class A, it is an apple. So many fruits are there. So it is class A is an apple. Then class B is also giving us apple. Then tree N is giving a class B. Class B is a banana. Class B is a banana. Now the majority voting process happens or averaging happens. The final class output is coming as apple. So basically what we want to try to do is how many apples are there or which fruit is majoritarily available in that fruit box we want to find out. So based on that, we provided so many decision trees. Finally, we found out the classes apple class. So this is how the random forest works. This is how the random forest works. So decision tree is one of the integral part of the random process, random forest. Okay, right. Now coming to the k-means clustering, right? So this random forest can be unsupervised learning also. Can be used for unsupervised learning also. Maybe a supervised learning also, depending upon the designer how he designs this algorithm. Similarly, the k-means clustering is also can be supervised or unsupervised. sorry. Generally, it is taken as a unsupervised learning. Generally, it is taken as a unsupervised learning. So there are groups are available. There are data points are available. Now all the data points are clustered into a groups. So this is the general data points. It is given to the k-means algorithm, clustering algorithm. So clusters are formed here. Okay, the number of clusters we can design. The number of clusters we can design. If we are designing 2, there will be 2 clustered of data will be available. If you are going for 3, 3 number of clusters will be available. And again, this number of clusters and all decided based on the problem. So if you want to have more accurate classifications, more accurate clustering, then we got to increase the number of Ks. Of course, it will increase the computational time. Computational time will increase. So there we got to do the balance based on the problem, how much accuracy we want. So all those things we can decide based on the problem. Based on the problem, we can go for deciding number of K. So this is about k-means clustering. So this is about k-means clustering. Right. Now, I'm coming to an end. So this is the summary of machine learning types. This is a summary about the machine learning types. Here, it is included with the semi-supervised learning here. As I told you in the beginning itself, there are certain classes are there that is called semi-supervised learning, right? So we will see what are all the major benchmarks of this machine learning types. So supervised learning, we may have 2 different target variables, continuous target variable or categorical target variable. So when we are going for categorical target variable, it is called classification problem. When we have a continuous target variable, it is called regression problem. So a simple example is for a regression is housing price prediction. For the classification is medical imaging. Okay. Now coming to the unsupervised learning. So for the unsupervised learning, if the target variable is not available, so that is called unsupervised learning. So this unsupervised learning can be classified into 2 types, clustering and association. So for the clustering, we can give an example, customer segmentation. For the association, it is market basket analysis. Market basket analysis. Suppose if we have a categorical target variable, right? So in here, we can have a classifications as well as clustering, right? Okay. So classifications will have like a classification of the text, or if you are going for clustering, it may be land finding on GPS data. So these are all some examples for semi-supervised learning. Then coming to the reinforcement learning. So reinforcement learning, again, we can have 2 different outcomes or 2 different targets, like categorical or target variable is not available. So if the categorical target variable is available, we can go in for classification based on the reinforcement learning algorithm. So one of the example is optimized marketing. Suppose if the target variable is not available, we can go for control. So controlling algorithms of reinforcement learning. So like very simple example, driverless car, right? So this pictures gives about the summary of machine learning algorithms, what we learned. I think I am done with this PPT. These are all my references. Mostly I have taken from internet only. I have not referred any books. A lot of materials are available in the internet. We can Google it. We can get it. So I referred these for pages for preparing my slides. Finally, I want to thank to each and every participants who listened to my lecture, and I want to conclude with my with the Mahatma Gandhi quote. It is health that is the real wealth, and not pieces of gold and silver. So take care of your health. So that is very important. So the wealth we can create it. So health has to be maintained to create the wealth. Okay. That's all. Thank you. I'm open to answer your questions. If you have any questions, you can put it in chat box.
Sir, Karthikeyan sir.
Yes, sir.
One question received from the participants earlier. Yes, what is feature engineering?
Feature engineering. Whether he is asking about feature extraction?
Yes, sir. Yes, sir.
Yeah, actually, when we are going for principal component analysis, what we will do is we will club the feature. I mean, let me go to that slide. Yeah, basically, the groups will be formed based on the features. So we will try to associate each and every data with the features. From the features, which is dominant feature for that particular data will be extracted. That extracted feature will be used for training the algorithm. So that is called feature extraction. Instead of giving all the data to the neural network or algorithm to train it, so which will take time. So the important features of particular data set is taken and that is given to the algorithm for training it out. So that is called feature extraction. Yeah, kindly suggest machine learning book to learn from the scratch. Of course, I am not referred any machine learning algorithm. Maybe Gomadi can recommend any book. Sir, Gomadi sir, any recommendation for the machine learning book?
Sir, from orally, they have one of the biggest hands-on machine learning with scikit-learn and keras and TensorFlow. That is, I thought, so useful to us. If you want to learn machine learning with the help of scikit-learn or keras or TensorFlow, you can use that book, sir.
Okay. I think it is answered. Is there any other question? Okay. If there is no questions, over to Govindanayan sir. Thank you.
Yes. Thank you, Karthikeyan sir. We'll share the feedback link to you. Participants, kindly fill the participants. We will share the feedback link every session. That only we will consider as a attendance from you. Kindly fill the feedback. Sir, if you want to give some instruction to them, sir. Karthikeyan sir.
Yeah, actually feedback will be available for only 10 to 15 minutes. Please try to fill up that feedback link as quick as possible. So that feedback link will be taken as attendance for your sessions, right? Attendance for your sessions. All these PPTs and slides will be shared with you through your mail. So we have your mails. We are collecting your mails from the feedback links. So all the slides will be shared with you, right? Please try to attend all the sessions and try to interact more. Try to interact more with the presenters. So more hands-on sessions are going to come in the next sessions. Please try to interact with the experts. And final day, we will be having the evaluation test also. There will be a quiz. You have to clear that quiz to get the certificate. Yeah, Mutayan sir, that book is already, sir has posted it. You can refer it. Mutayan Ramadas sir, you can refer that chat box. Komadinagam sir typed that
இதை மட்டும்
textbook. You
மாற்றணும்.
can refer that textbook. Yeah, that's all. That's all. Please fill your feedback. Yeah, the next session will start at 2:30.
All the
next
participants are requested to join by 2:20. Purely that's a hands-on session. They started from the Google Colab. I thought so. So many of you, you are from different departments. So we will start from the scratch. So participants kindly make it useful.
Yeah, if you are attending from the laptop, you can do hands-on session in parallel with the expert so that you will get the idea. So we request to have a laptop with internet connectivity so that you can do hands-on sessions on your own. Of course, if you are not having, no problem. This recorded videos will be available. It is available in our YouTube link. That link also we can give you. You can get it up and you can listen to it later on. You can do it on your own.
மொத்தமாக செலக்ட் பண்ணிலாம் இழக்க முடியாதா?
Participants, please fill your feedback link.
Participant, do you have any queries or any doubts? You can able to clarify with the resource person.
Please join the next session at 2:20.
இதில் போயிட்டு இப்போ ஸ்டாப் ஸ்ட்ரீமிங்னு கொடுத்தா போதும், அவ்வளோதான். அப்படிதானே? சரி, எல்லாரும் போட்டோம். அவ்வளோதானே, சேவ் பண்ணிடுங்க, அவ்வளோதான். இருக்கட்டும் சார், டைம் ஆச்சு, போதும் போதும். மெக்கானிக்கல் செமினார் ஹால்னு நம்ம இப்போ காலேஜ் நடக்குது அப்படின்னு தெரிஞ்சுக்கிடுவாங்களே. சரி, பரவாயில்ல. எப்போ டிசம்பர் 1 தானே, பரவாயில்ல. சேவ் பண்ணி இமேஜ் அனுப்பிச்சி விட்ருங்க எனக்கு. சேவஸ் கொடுத்துருங்க, இதை சேவ் பண்ணிடுறேன். இது நாகேஸ்வரியோட இதுலேருந்து எடுத்துருக்கு. ஓகே, சரி, நான் இப்போ ஸ்டாப் ஸ்ட்ரீமிங் கொடுத்துட்றேன்.